This video is going to go through notes on translations. We're going to go through some definitions real quick, and then we'll talk about translations. We probably all know this, but just so we are all on the same page, we know that the coordinate plane is separated into 4 quadrants, 4 sections, and they're listed here, and they go in order of 1, 2, 3, and then 4. In this first quadrant, both x and y are positive, so my coordinates would look like this. Both x and y are positive. In this quadrant, x is negative, but y is positive. In this quadrant, they're both negative. So notice in these two quadrants, first and third, they're both the same, positive, both positive here, both negative here. And in this quadrant, x is positive, but y is negative. So it looks like that. A translation is the first transformation that we're going to talk about in detail, and it is an isometry. And if you recall, an isometry means that it doesn't change shape or size, it just moves. So all points in the pre-image, which is the image you're given, are moved parallel to a given line. It's going to have the same orientation in a translation, meaning the letters are going to be in the same order. It's going to be kind of tilted the same way. It's not moving, it's not rotating, which would change its orientation. It's just sliding. It's a rigid movement, right, left, up, down. In this translation, you can see the parallel lines that are drawn in that we are moving along. Notice that these two are congruent, and again it maintains that orientation. One thing to note about the notation here, ABC is the pre-image. It's before I move it, and then I have ABC over here, but here it's A prime, and that A prime just means that now it's the image, or it's where it is after I move it. So the pre-image is before I move it, the image is after I move it. Translations are described by the distance that each point is moved, so how far the x is moved and how far the y is moved. We're going to look at a couple of different types of notation, and one of them is this right here, and that's telling me that T means it's a translation. We'll look at, what does that look like with a reflection and a rotation, but capital T is a translation, and H, comma K is for the X and the Y values that it's moving. So if I'm moving it H for X and K for Y, then I would add H to X and add K to Y. When we look at it with numbers, I think it'll make a lot more sense. Alright, so I have the coordinates of a triangle CAT. So here are my coordinates for triangle CAT, and I could go ahead and graph those, but I've got the coordinates of this triangle, and it wants me to move them or translate the vertices according to this right here. So that means that I'm going to move 8 to the left and 2 up. So my whole figure is going to move 8 to the left and 2 up. So that means each vertex, or each point that I'm given, C, A, and T, have to be moved to 8 to the left and 2 up. So the x that's going to change is going to change by -8, and the y is going to change by 2. So that means C prime, or my new C, is going to be -2, and -8 is -10. And then 4 and 2, because that's what I'm adding to the y value, is 6. My new A value is going to be A prime, 0 and -8, which is -8, -8 and 2, which is -6, and my new T prime Negative 8 and negative 3 is negative 11. 5 and 2 is 7. So C prime, A prime, T prime. By moving each vertex according to this, 8 to the left and 2 up, I've taken the whole triangle and moved it 8 to the left and 2 up. The second example is slightly different notation. I'm still looking at a transformation, but here it just tells me specifically, okay, add 2 to the x, subtract 1 from the y. And I've got the vertices C, H, and S. So for each x, I'm going to add 2, and each y, I'm going to subtract 1 according to the rule here. So x is 1, 1 plus 2 is 3. For C, my coordinate C, I have 2, so 2 minus 1 is 1. So that's C prime. H prime then would be negative 3 plus 2 and negative 5 minus 1. S prime, 4 plus 2 and negative 1 minus 1. So these would be the new coordinates. So again, just like the previous example, I have the vertices of a triangle, and I want to move the whole triangle 2 to the right and 1 down. And if I move each vertex 2 to the right and 1 down, then the whole triangle will move that way as well. Alright, this one is going backwards a little bit. It asks me to find the vertices of the pre-image if the coordinates of the image are. So basically they told me the triangle moved, and here is where it moved to. We've got to go backwards and find out where it started. So we're finding the coordinates now for W, A, and R because they gave me W prime, A prime, and R prime. So when you look at each of these, for my x value, whatever x was before, I added 12 and got 5. So what do I have to add 12 to get an answer of 5? Well, I can just go backwards. 5 minus 12, instead of adding 12, 5 minus 12 is negative 7. And then test it. Negative 7 plus 12 is 5. Alright, going backwards again, I've got negative 29 and negative 17, so I'm going to add it instead of subtract it. Negative 29 plus 17, which would be negative 12. Right? A, 20 minus 12 is 8, so again I could check myself. 8 plus 12 is 20. And then negative 19 plus 17 is going to be 2. Again, check myself. 2, negative 2. Negative 19 plus 17. Negative 2 minus 17 is negative 2. And then R, 21 minus 12 is 9. Sorry. And then negative 4 plus 17 is going to be 13. So basically I did it backwards. Whereas in the previous ones I was given this and I went to W prime, A prime, and R prime. Here I went backwards. Alright, in this case it's asked me how far and in what direction does the point P move when translated by this function? Well, it would move 24 to the right and 10 up because this is what I'm going to add to the x, this is what I'm going to add to the right, to the y. So I could describe it like this. Or I could describe it in words. 24 right, 10 up. But you'll just have to check and see on a multiple choice what those answer choices would be. Alright, looking at the actual figures themselves and now translating it. Here is this figure, and it wants me to translate it 4 to the left and 1 up. Well, just like before, if I take each vertex And actually, let's not go to the left. Let's go to the right. Because based on my graph, that would be tough to go to the left. So we're going to go 4 to the right and 1 up. So I'm going to take each vertex, and I'm going to move it 1, 2, 3, 4 to the right and 1 up. Once I do that, I'm going to label it T prime. Take this vertex, 1, 2, 3, 4 to the right and 1 up. Label it E prime. And I, 1, 2, 3, 4 to the right and 1 up. That's I prime. When I connect the dots, my whole triangle has moved 4 to the right and 1 up. Notice it's in the same orientation, meaning everything's in the same direction. Letters are in the same order, same shape, same size. It's just moved positions, a rigid, so just straight to the right and straight up. Alright, in this case, all I'm doing is taking it and moving it 4 up because the x is not adding, we're not adding or subtracting to the x. So I'm going to take everything and just move it straight up. So 1, 2, 3, 4, label it x prime. 1, 2, 3, 4, label it g prime. 1, 2, 3, 4, label it q prime. And 1, 2, 3, 4, label it u prime. And then connect my dots. And that is my translation for up. We're going to talk about rotations and reflections in the future, but you're starting with the most basic, which is a translation.